So, what we are trying to do in next 30 minutes is to explore QMD and understand what it does good, what it does not do good, and what are its clear advantages over just using Bash and grep. So, our idea is that we have a bunch of MD files. We will let Py rip it first using Bash, grep, and whatever. And then we'll see how we can use QMD to get more out of it. And this is the basic idea. Of course, we'll be interested in how it works, and while our agent work, we need to do something. So we'll go inside the QMD and we'll also see what it does, how it does it. This is designed to be more of our exploration and the way we approach things and learn. So feel free to give suggestions and off we go. So, Sagar, do you have something to add?
Yeah, definitely. So, like few days back, we were chatting about a few things around retrieval, and uh, naturally, Abhishek started talking about QMD, and the entire discussion went on and on for almost an hour. And we thought, ki, hey, like we are doing this entire thing very naturally, and probably it would be best to put out our learnings to a larger audience. In the meanwhile, also learn as we create this content and keep on expanding our knowledge base as and when we read something new. So I think this is our effort to do that. And yeah, as Abhishek mentioned, it would be a mix of implementation as well as explanation of what QMD is. So yeah, like let's just get started.
Yep, yep. I'm just sharing the screen. I hope it's visible.
Yep.
Let's go. So moving to this. So this is our own friendly fog pedal. And
Increase the font size.
yes, yes. Um, what was the file name though? Do
Uh,
you
testing,
remember?
testing physical intelligence.
Okay, that's not a main branch maybe, right?
No, no, it's on the main branch. Can you go to docs and guide? Uh, Guides, yes. Uh,
Awesome.
it's weirdly not being indexed. I, I don't know why.
Yeah, yeah, yeah.
So yeah, like this is one of our reference files which will be showing up for our demo. Like this is a data set of lot of papers associated with robotics, AI, and we'll be cloning this and we would be trying to index it with QMD. Abhishek, over to you.
Yeah, let's get started there. While this indexes, we're using red, by the way.
Yeah. So
And there you go.
just a disclaimer, like we are removing PDFs. Um, so this is deliberate, but QMD has a way to mask other files, but we are just doing it for the sake of doing removing PDFs. Cool.
So, by the way, going back to how to install QMD, let's go to the GitHub repo, let's go to the source. And this is a very nice diagram. You know, you take a query and they have like Quen with their own adapter, which will make three queries and then do a parallel search and then do a fusion with the local reranker and then get the reference. And I work at a company where we do retrieval day in day out, and this is very close to SOTA, and so we do this at an infra layer, but like doing all of this locally is something that we only has uh, packed the SOTA in a CLI basically. So
True.
that's also very interesting. Still waiting for it to clone. So
Yeah, I think that was released last week. Awesome. And the first order of business will be collection, and then just embed. That's it. So once this guy, yeah, okay, fine, downloaded, and we And we then copy paste, remove stuff. Did I enter? No, wait.
It
This
removed PDFs. That's fine.
did it. Oh, you. Oh, we did it in like root. Okay. I need to go to root then, right?
Yeah, in home folder.
And this is done. And then let's do it this way. What does update do though?
So it will basically update any existing index. If it's not created, it will just create it and then update it. So probably that.
So we just kept this for now.
Hmm.
And let's go. Yeah, this is some problem with my node llama cpp. It
Okay.
just so it falls back to CPU.
Mhm.
It doesn't use GPU.
Yeah.
Although I do have a custom llama cpp build for MLX,
Oh.
but I have trouble QMD detecting and integrating it. So
Mhm.
that's something.
Okay. So can you just go back to terminal? So here, like what is happening is the QMD is downloading few models which are required for converting the context chunks into embeddings.
I think model is done, right? This is the model. I already have the models. This is
This is
chunking
chunking.
for now.
Yeah, this is chunking. Okay, yeah.
Yeah. If I see my activity monitor, I think the CPU spike would be pretty obvious. I feel so. Yeah. Node. Yeah. Node taking up all the CPU. Cool. So yeah, while this happens, it will take like roughly 14 more seconds. So we plan to use it with Pi, and yep. So all of this is done. So roughly, the documents were long enough that every document got roughly 2 chunks, give or take.
Yep.
And maybe I can show you what is in the repo also. So this has research finding
You can
and
go to papers.
papers.
Yeah.
And this is the most important part: NVIDIA Cosmos, music, MCP, Masala, no, not music. Okay. All right. So let's do this thing firstly. Um, let's ask Pi some questions.
Also, yeah, you can refer to the same exact question which we will be demoing after this, right? That would be better benchmark.
Same question. You mean?
There was a demo MD that I shared, right, like earlier. Testing physical intelligence.
Yeah, we
That.
have this, right?
Yeah. So here, for example, we are doing search attention, search transformer, some, and like we can put in this same queries or similar queries in Pi as well as QMD later on.
So
Let's
there
see.
is, yeah. So let's see what QMD search does. This will do a fast keyword search. vSearch will do a semantic search, and query will do everything.
So
So
it will,
then QMD search is effectively ripgrep, right? Or
yeah,
grep.
yeah, it will do like glob like search as well as so here it uses some special kind of search. It is called as FTS5, which is full text search, which is a reverse dictionary, meaning every word points to a certain row. So that way it will search through the
But this
entire.
is an exact search, right? Like exact finding
Yeah,
for Control F, basically.
exactly. So full text search.
Yep. But if I do attention this way, then I get. So how many results did I get? 1, 2, 3, 4, 5. I think top 5. So let's do it left and right, okay? Let's do attention and let's do QMD attention. And so this is attentive probe accuracy, NVIDIA Cosmos, JIPA, Act JIPA. I think those are 4 important ones. These guy got multiple matches in Act JIPA, and then hence that is first because 1, 2, 3, 4, 4 occurrences. And then 1, 2, 3, 3 occurrences. So then attentive probe got second. And then everything is, oh, interesting. NVIDIA Cosmos got a lot of attention matches, but it's still ranked low. And okay, so is the order stable? So if I do this again, do I get the same order? Yes, I think so.
Yep.
I'm also wondering whether this is like sorting by just a file name, ActJapa A C A. That could be a possibility, but nahin, because L. No, so I think RibGrab does try to heuristically say that okay, it occurs 4 times here, and then hence it's at top. I'm not sure then why this is not at top. Interesting. And what QMD does, it tries to give more weight to title somehow.
No, it's like partial matches, right? Like so ATTEN, these words are being matched first, and like then the full word. So partial and full word kind of matching is being done, is what I believe.
Yeah. So full word is given more weight, and the
Yeah.
title is given more weight.
Yep.
It seems.
Mm-hmm.
Or यहाँ पे it's just the number of occurrences, like so all of these are given weights for now. And of course the title, but
The title is being matched as well.
yes. Correct. So let's run a few more queries. Let's see.
So we just did like search. Maybe we can switch to a different type
Vector
of
search.
Yeah. So the next one, right? Vector search. Yeah.
So let's clear this and then let's do vector search. Okay. So this launched like 3 queries.
Can you zoom in a bit?
I can. So this did 4 queries. One is the exact query as it is, and then 2 are vector queries, which is how attention works in models and importance of attention in processing text. Okay. And then there is hypothetical document generation, which is the rough answer where the hypothetical answer, which may or may not be accurate. But you use that for matching the cosine similarity.
Okay. So this was generated using the same Llama CPP that we have, is it?
Yep. Everything is local.
Got it. Cool.
Yeah. So they do explain high day part of it. Yeah, I don't think it's in README, but yeah, this is a hypothetical answer basically.
Got it. I'll just run a py query on my terminal, and probably we can show that. But yeah, like let's just carry on until then.
Yeah, it is matching like information for an information. Interesting. So, and then, okay. Oh, right. We did not give it a collection. I had another collection as well. So it also tried to search in there.
Oh, can we
Yeah.
exclude a collection by any chance?
we can.
Okay.
So there'll be like robotics research, and then it will only search in that collection.
Okay.
So attention mechanism for selecting important tokens. I think attentive probe accuracy is the closest, and then everything else is noise at this point. This is all noise. Okay. So, but then let's try this thing, right? Let me copy my mcp.json here,
Mhm.
and let's see. So this is like 8901, which is where my QMD would be running as an MCP. So, okay, this is not running right now. So what we can do is we can run QMD MCP, right? Now
Yep.
this is running. And then I can give the same query to my Pi that, hey, attention mechanism for important tokens, find me papers. Oh, let's just first check whether, yeah, it has QMD, right?
Yep.
So find me papers. Let's see what other QMD queries this will do.
So you don't have to explicitly mention QMD over here, is it?
I don't have to. Let's see.
But it started doing RG, right?
Let's see. I think I have to mention.
Yeah, I'll let it carry, complete it any which ways. We can launch another query on different Pi with QMD.
Yep. So I'll just copy this. I'll paste it here. Remove this and say use QMD MCP, please.
Is it enabled though? Can you
Yep.
check that? Okay.
Yep.
Yeah.
So it is saying that you tell me how this works. My best guess is, yeah. So you can see like important tokens and papers that use attention mechanism, and then the paper that use attention mechanism, based token selection and pooling mechanism to choose a small set of important visual tokens. The query rewritten is slightly different because it is looking for papers. So I think we should also do this. And yeah, you see, like it is getting tool calls, right? The
Yeah.
multi-get and query tool calls are here, which is of course this multi-get and tool calls. Also, we were trying to do this,
Research.
and we will add this find me relevant papers, and we will observe that whether it writes the same queries or not. No, it didn't write, Ray.
Oh, what happened?
It did not write the paper specific lingo to it.
I think
But I
it's.
think in Heidi it did write find something.
You can check the server once. It might have a query, maybe.
No, this will load. This will not go to MCP server, right? This will locally load and load the model and then do it. So this is taking long. Let's see what it did. So first call was done to QMD with these expansions, and right. So this expansion was done by Pi, right? So this expansion was not a local model doing it.
Yeah, exactly. So it is a hybrid of like your model. Like I think you're running.
I'm
like what-
running GPT 5.5 high.
Yeah. So it will do a bunch of tool calls. It is an example of what they say agentic search. I think.
Yep.
So yeah, here
So
agent is
It found like 12 results for this thing.
So in that case, it was Llama model doing the hard work of
Yep.
rewriting the query.
Yep.
And here it's more of your GPT 5.5 or any other model. It will do a lot of agentic tool calls, tool searches to get to the exact thing that we have asked for.
Yep. So this query rewriting is way better, of course, right? Because this is getting the specificity of that I want a paper related to this and
Yeah.
visual representation related to this.
Correct. So, like one thing to note here probably is that instead of using it locally, it's best to use it with some with some standard model like GPT 5.5 or maybe Claude or DeepSeek. That will give you better results is what we can see. But at the same time, it might also be slightly longer query, and it would take some more time as compared to plain QMD query.
Yeah, so plain QMD query helps to, of course, do all of this, right? Let's go back. This guy returned fast, right? This was pure rip grab, right? So
Yes,
all it did was like one of this and one of this. That's it.
Mhm.
And then read like 4 papers and then told you whatever.
Correct. So this is one. So here, like as we can see, it is trying to check through like few keywords that we have asked it, and it has come up with some additional keywords to regrep.
And globs.
Yeah, and it will just blindly search for all the keywords in whatever papers you can find, and I think it will do some reads and then return you results. You can scroll down. Yeah, so as we can see, it has read a few papers and then it will try to generate a summary. But this is a shallow way of finding keywords in MD files or any search space for that matter.
Yeah, this is only taking care of the keywords. Like there's no semantic, there is no hybrid search running. And let's see what this says, that token learner is one paper, dynamic wit is one paper, and closest papers are, which is VJEPA, which is attentive probing, and VJEPA 2, which is same idea but 4-layer probe.
Good.
And let's see if this comes up with it's been running for long enough. This guy is like, I'll uncover the world today.
Yeah.
I wonder like if NVIDIA Cosmos was even like an option considered in this.
No.
I can I do control? Oh no, I can't, right? Oh, one thing I can do, right? I have agents view.
Okay.
So I can, if I have port, I can run this on 8903. Okay, where it's serve. Yeah, serve. Okay, serve. It's syncing all this up, and then let's go to localhost. You don't watch my other agents, so
okay. You can just hide that maybe. Okay, so it's going on. So this is our the one which is running.
Yeah, this is one which is running a lot of MCPs, QMD MCPs, and 28 tool calls so far going on. Oh, there is a result, right?
It's done. So it found out similar. So VJEPA 1 and 2, those are like similar papers. NVIDIA Cosmos was not there in the results, right?
And token learner. So, okay. There's one interesting. Before we do that, I want to know. Yeah, it took like 52,000 tokens in and 4,000 out. And I want to know sort of how long it ran. 5 minutes.
Okay.
Right?
Yep.
And let's go to the other. I think this was.
Yep, this rip, yeah.
Yeah, this ran for just 1 minute. And just did 6 tool calls, and it's like, done, sure, done.
Number of tokens.
Number of tokens is half.
20.
That was like 52, this is 26. Yeah. And that's like 4,000, this is 2,000.
2,000, half, exactly.
Exactly half. So all right, and then this guy came up with that if you want most exact, then that is token learner.
Yeah. And here there's no NVIDIA paper.
So I still wonder, like, is it like a token learner is the paper that we are looking for?
So probably we can spin up another Pi agent and ask it.
Okay, let's see.
Let's try.
But did it even say JPA? It didn't even say JPA.
Oh, okay. So closest paper in your words, right? The bottom one.
One sec. I'm just opening them in two different tabs. I'll just zoom out a little so that we can fit it in one screen. So this is like JPA is your top thing that you should read, right?
This is QMD, right?
This is QMD. But if you don't use QMD, then this is token learner is what you should read. And there is no mention of JPA at all.
No, if you go to the bottom results, like closest papers in your world, it has.
Yes. Okay. Yeah, this one I missed.
Yeah. Probably.
Explains the mechanism directly. Okay, so this is there. And then there is no mention of that part. Okay, so most direct answer is because attentive probe accuracy metric describes the cross attention selecting task relevance tokens, and that is described in VGPA and VGPA2. I haven't read token learner, so I don't think I'm in a good spot to say whether.
Yeah, that's what. Like, it's fine. But probably we can just ask Pi, like, which are better results. This is query 1 result. This is query 2 result. Which
Let's ask it to
retrieval,
re-rank basically.
yeah, which retrieval mechanism did the best?
Yeah, probably. Yeah, no worries. This was the original query.
10 tmux is running right now.
So come on, copy, paste.
So second one is QMD, right?
Yep. Trying to fetch the original query. Okay, I can go here. Like simpler. Okay.
It wasn't okay, huh? So much for using CLI.
Yeah. Cool. So I think we probably should like choose a better example where I can judge maybe. Yeah. But I can show you like I have a slide set up around these lines on my agents which run on QMD. Okay. The law of demo says the demo should not work. Interesting. I broke something. All right. Interesting. So my demo does not work.
Yeah. That's fine, probably. Like,
Yeah. Fine for now.
benchmarking later if.
Okay, so because the phrase is most directly describes token learner. Interesting. So RibGrab got better results, not QMD.
So much for demo.
Yeah. And why not other? Because of attentive probing, where the learned queries attend over frozen visual tokens. But this is mainly a eval mechanism, not the central contribution of the paper. Okay.
So, like, one reason why I feel like this could have happened is because like it does two types of queries, right? Like it splits into full text search as well as vector search, and it tries to come up with a combined approach to sort of get the results. Another reason why I can think this could have
Yeah.
happened
Did you read this, by the way?
is most relevant. VJPA is most relevant because
I'm
okay.
still wondering, do we even have token learner now?
Yes,
Uh, I
do.
don't have token learner, but do I have JEPA? I have
Yeah,
JEPA.
JPA is there.
But
No,
the token learner is not even there, is it?
you can just ask it or like get me
Where
file.
where
Get
is
me.
this file?
Uh,
Like,
I think it would be a different paper.
I think, yeah, I think it's like general knowledge of GPT is like so good. That's like, yeah. So,
Oh, oh, nice. It
so
has created.
it just told you, ki, hey man, the answer is not here, but then you go and read this.
Oh, like we
Interesting.
should have been better prompters, I think. Uh, saying ki, hey, just
Yeah.
restrict yourselves to this repo.
Yeah,
Uh,
and then it says, oh, right, right. So you see, like attentive probe accuracy and JPA is what it read, and then it realized ki this is probably the answer, but not.
so over here in thinking stubs, right? Generating a paper list, I need to create a concise list of there itself, yeah. Which relates to token learner, and its paper is titled "What Can 8 Learn Tokens Do for Images and Videos?" So this is something that it came up with. It's not present in our papers.
So GPT is smart. It knew that you want this paper, but what is closest you have,
Okay,
and then
so
we didn't have it. So it's like if you ask me to answer the question says that find me papers. I didn't say to do it from the vault.
mhm.
I said,
Yeah,
what are the papers? It says, yeah, token learner is the paper you're looking for.
yeah. So GPT hacked our retrieval. It did not use it directly. So cool. Yeah, I think that's that.
Okay, okay, right, right. One more thing is that it seems to be a need to search the vault. So it is aware, and it's using a grep could help me find exactly what I need. I want to ensure that user gets the most relevant information. I think this was like a key thing that it was hinging on, right?
Yeah, yeah.
And then it did uncover the vault and then didn't find anything. And I need to clarify one sec.
Huh.
So I need to, so it didn't find anything in the vault probably. And then it's like, what does it mean? It means token learner because that's what
Mhm.
GPT remembers
Yeah, yeah.
from its big brain. And then it says that then the papers and metrics related to attentive probe might be a good idea.
True.
Right. So this is
Yeah.
mostly GPT doing the hard work of
Instead of
realizing that this is token learner.
yeah.
So this is also one of those reasons, right? One of nice findings, right? Where if you ask it to follow something which you think might be important,
Mm.
it might not give you the best result though.
Yeah, yeah, true, true. So
Because
like
here we assume that this would be in our vault. Right.
correct, correct. And like that's where I think grounding these searches to real data is important. So that's where like retrieval systems like QMD get an edge. So like agentic retrieval using ripgrep would work to a certain extent. And
All right.
yep, it started. So yeah, like we saw everything live right now, like how QMD works, just working through CLI, what are various options available, and like let's try to get into slightly depths of it as to how QMD actually works. So like how is the structuring of code, what it exactly does to give you the results that we just saw. So let's just start with what QMD is. Like QMD is again a local first search, meaning all your files, all your retrieval mechanism, all the things that a cloud retrieval system provides you is provided to you in a local manner. So here in this diagram, you can see markdown folders or any plain text folders are present. You need to index it first. So when you think of any retrieval system, right, there are like few stages involved wherein you have data store. Once you have the data, how do you index it? That is the first question. Once you have indexed it, how do you fetch it? Whether it is keyword search, whether it is semantic search, or there is some hybrid way of searching through the existing documents, right? So these are like various ways of searching through a data set when it comes to vector search. When it comes to retrieval. And then finally, when you have results of each of these branches, you combine all of these results in a meaningful way and then present it to an LLM or the user who is going through the results. So this is pretty much what QMD does. So here you can see we are trying to build an index, and there are three ways in which QMD is searching. One is like BM25 keyword search, other is vector semantic search, and hybrid query plus re-ranking. And finally, you combine all of these meaningful context to generate results. So again, like we just saw something what ribgrep does and how agent plus ribgrep performs agentic search, right? So QMD is trying to offer a much better solution, which is grounded to the real documents that we are trying to search from. At the same time, it's not just doing grep. So it is doing keyword search, but it is also combining it with vector search. So we are combining best of both worlds, and we are trying to come up with something better. So that's what QMD is trying to do. And as Abhishek mentioned earlier, like I ran a small query, like what is hide, and give me a small explainer of it. So as he mentioned, it writes a fake document, which fake ideal document, and you try to sort of ground your final answer to this particular document. So that's what hide is. Okay, who is it for is very clear, I think. Yeah, let's just go to the architecture. So if you look at the code base that QMD is structured in, so there are like various surfaces which you can interact with, right? So there is a CLI, which we just saw in the initial part of this video, where we do QMDV search and give a query. That is CLI. SDK is basically the library that you can use to build on top of. And MCP is something that Pi harness or Cloud Code harness uses it for getting the results. And once you have these interfaces, the main core crux of it is how you store all of this information, right? So here, like there are various subsystems wherein like there is a DB sitting in there. There is an LLM which encodes these chunks that we saw into vectors, and basis those vectors, you try to do a similarity search and come up with relevant chunks for finding what we want. And yeah. Yeah. So let's look at the core of like how search works over here. So initially, what happens when we give a query to this particular QMD? So whatever query we give, the first thing that comes up is BM25. BM25 will try to do a keyword search, a probabilistic search, wherein it's more like TF-IDF, term frequency, inverse document frequency, wherein you try to give weight for term frequency slightly lesser, and you try to probabilistically search for keywords in your document corpora, right? So based on BM25 search, you will try to understand whether this query is strong or not, right? Once you make a sense of whether this query is strong or not, you will see does it need expansion. So whenever a query is given, it might not be the best query that you would give to retrieve retrieve the kind of document you want. At times, you need to augment that query. You need to rephrase that query in order to search better. So that's where expansion comes in play. If the query is not strong enough, LLM will try to enhance that query and then pass it again through BM25 and vector search. So once we have this, have the results of BM25 and vector search, you come up with RRF, which is reverse rank fusion, and fetch the chunks that are needed. Then you re-rank those chunks and results, and then you give the final results. So right now I don't know what RRF is. Let's just ask Pi what RRF is and how does it work in BM25. So I'm just going to ask that. Abhishek, do you want to add anything over here?
No, I was just writing a few things myself.
Mhm.
But I think, yeah, you have the answer before I can pitch in. So
Yeah. Okay.
So one thing while this does is that reciprocal rank fusion is important because your results are coming from different kinds of system. One
Yep.
of them is full text search, one of them is vector search, and both of their rankings are through some numbers,
So
but
we are
you are,
normalizing the ranks over here. So that's what it's doing,
yeah.
right?
So the core thing is that when you have like two list of documents coming from two systems, both of them may not operate in the same range in that sense.
Yep.
And
Yep.
both of them, I mean, somebody is in between 0 to 1, somebody is between 1 to 10. So the best way to combine them is via ranks, and then you inverse it, and then you get the formula.
Right. Right. So here we can see whatever rank we are getting, we are doing a reciprocal of that. We are getting rank of that particular document and adding it up. So we are trying to smoothen the kind of final rank that we get for each document after combining all of the ranks together. So that's what reciprocal rank is doing. So yeah, like that's about a search. Yep. Let's try to go through this together as to like how indexing works and what exactly it's trying to do.
Mm-hmm.
So over here, like whenever we initiate indexing or whenever we gave a query to, sorry, whenever we sent in a command to QMD to build the index, the first thing it does is does a global scan of what exists. So there are masks that we put in, right? Like we only selected the .md files. So the first thing that a QMD does is you filter out other noise, which we don't need to index. Once we have that, we just try to see what all needs to be indexed, uh, what all needs to be indexed in full text searches index, and if it exists you can just skip that and keep on building the index. So that's what we are trying to do over here. So here if it does not exist, you index that document, you put it in the index. If it is changed in some manner, you update that particular index and also update the full text search. So the FTS5 algorithm that this QMD uses is updated in this manner. Cool. Yeah, I think we already talked about what retrieval stages are. We can probably skip this. Yeah. So here again, as I mentioned, so in retrieval, like there are two parts. One is identifying candidates and then double downing on the kind of candidates that we have. So here we have a query and we try to split it into two different signals. One is keyword search and other is semantic search. And based on that candidate list, you get a re-ranker, and then sort of get the final results. Yeah, so this is more of getting the paths and the hashes. So at times, whenever you need to exactly find a particular file, this type of system helps you. So here you are trying to get exact name of collection and what path does the retrieved candidate retrieved result is present. Yep.
Yeah, I think just get and multi-get is just get me that document, just
Yeah,
read it for me. It's just a read bash read command, that's it.
right. So yeah,
Multi-get is like parallel tool calling, like parallelly read all of these. That's it.
correct. I think we have covered the core parts of it and like what QMD is. It's much more deeper than that, definitely. But I think we should just keep it short for now and probably conclude. Do you have anything to add, Abhishek?
No, I think यहाँ पे we can close it up and then ask people if they want us to try with new things, or we'll meet again. Let's see.
Okay, fine. See you in the next one, Abhishek.
Yep. Bye bye.
Yes, see you. Bye.